Hey guys, this is Miss Baker. I'm going to go over page 224. How do you create and name ionic bonds? Okay, ionic bonding occurs when one element donates an electron or electrons from another element to another element so that they both have elements that have full outer valence shells. Now here's a picture of it. Here's row 1. Look at sodium. Sodium has one electron on this outer valence shell. It is much easier for it to donate this electron to get down to this shell. Remember, the entire job for an atom is to become or get a full valence shell. It can do this in two ways. It can donate electrons or it can steal electrons. Okay, if it donates electrons, the atom becomes positive because it's got more protons than electrons. If the atom steals electrons, it becomes negative because it's got more electrons than protons, and it will become positive however many it steals. I'm sorry, positive however many it donates, or negative however many it steals. So look here. On row 1, you've got the same number of protons as electrons. When this electron is given away, you have one more proton than electron, so this charge is a +1. On chlorine here, chlorine needs to steal an electron to fill this hole to make this shell full. So when it steals this electron right here, it's going to have one more valence electron, one more negative charge. So it will become a negative. So the chlorine is a -1. That is what row 2 is showing you. See, row 2 is showing you no electrons in this third ring, so that makes the second ring the valence ring. On this chlorine, it has stolen an electron, so it is a negative charge, and its third valence shell is full. When donating an electron, an atom becomes a positive ion. It now has more protons than electrons and a charge of +1. Positive ions are given the same name as the element. The element symbol has a plus sign, so Na plus means there is one positive, extra positive charge. By gaining an electron, the atom becomes a negative ion. It has more electrons than protons and a charge of negative however many. In this terms, when we're talking about chlorine, it's -1. Negative ions are named by adding the suffix "ide" to the last part of the element's name. So what you do is you take the name, you drop the last syllable and put "ide" in there. Atoms with opposite charges attract each other. So positive and negative ions cling together to create a strong ionic bond. So how to do ionic bonding? So number 1, use the periodic table to find out if the elements are metals, nonmetals, or metalloids. Number 2, determine what kind of bond you are dealing with, ionic, covalent, and metallic. So we're assuming you have a metal and a nonmetal, so creating an ionic bond. Set your element symbols up with the metal on the left-hand side and the nonmetal on the right-hand side. Write the charge of each element symbol in the upper right-hand corner of the atom as a subscript. Place the Lewis dot structure around the symbol. Transfer the unpaired donated electrons from the metal to the missing nonmetal electrons. If the pairing of the electrons is not complete once the paired electrons are completed, add another of the opposite element until every atom has a full valence shell. Now, this is going to continue, but there is a max of adding a total of 4 atoms of any material. You will never have more than 4. So I know this sounds all like gobbledygook. So what I'm going to do is I'm going to go ahead and show you this. All right, so I need to go out of this mode. I need to split screen, and I've got to pull this over here. I'm going to change this so I can see more of this. So you can see what I'm doing. All right, so lithium. All right, lithium has one valence electron. So what I'm going to do is I'm going to delete all of these other electrons. So, and lithium has a +1 charge. The reason I know lithium has a +1 charge is it is in the first column. Anything in the first column has a +1 charge with the exception of hydrogen. Anything in the second column has a +2. Anything in the third column has a +3. The fourth column has a plus or -4. The fifth column has a -3. The sixth column has a -2. The seventh column has a -1 charge. And the eighth column has a neutral or 0 charge. So when I look at fluorine, I see fluorine has a -1 charge. So a -1 charge means it is missing one electron. So I'm going to change this to a 1. So 1 minus means -1. And then I'm going to delete that electron because it has 7 valence electrons. I know that because I've counted over columns. 1, 2, 3, 4, 5, 6, 7 valence electrons. Okay, you see this right here says you are missing an electron. A -1 means you are missing an electron. A +1 means you have an extra electron. Okay, so what I'm going to do is I'm going to put a box around this. I'm going to Control-C, Control-V. It'll make another copy. When I hover over it, it's going to put a plus sign and allow me to move that. And I am using these as my templates. Control-C, Control-V, and pull it over like this. Okay. Now, the next thing I'm going to do is I'm going to donate this electron to this Lewis dot structure. Lithium has now 0 electrons in that shell. That's good. It's fine to have 0 electrons. That means the next shell down is now the valence shell. This one's shell is full. Okay, this one's happy. Remember, it either wants 0 electrons in the shell that it's showing you or 8 electrons in the shell it's showing you. Now, the next thing you're going to do is you're going to type your formula. You're always going to type your metal first, so that's lithium, so it's Li. And then your subscript is going to tell you how many lithiums you have. In these terms, you have 1, so we don't need to write anything because we don't write a 1. Now, the next one we have is fluorine, so F. Again, you have 1 fluorine, so we don't need to put a subscript. The name, we're going to rewrite our names, lithium, space, fluorine. Okay. Now, because this is an ionic bond, we're going to change "ene" to "ide," and that's all we do. Okay, this one is totally done now. So let's go to the next one. The next one is lithium again. Lithium is a +1. Okay, I'm going to make this one a little bit smaller. Let's see if I can. Hold on. There we go. And oxygen is a -2. I know oxygen is a -2 because it is 2 away from carbon. Carbon is a plus or -4. I'm going to go backwards now, -3, -2. I also know it has 1, 2, 3, 4, 5, 6 electrons. So let's delete this electron and let's delete this electron. That is showing it is missing 2 electrons. Okay. Lithium has one electron to donate, so it only has 1 electron all the way around it. And what I'm doing, how I'm deleting my electrons, is I'm just clicking delete. Now on your page, mine is an updated version of your page. I can't change your page. So what you're doing is you're looking for the red electrons here and the blue electrons here, and you're just putting them in, moving them up and putting them around in your Lewis dot structure. Control C, Control V. I'm pulling this over here. I'll grab this one. Control C, Control V, grabbing it and pulling it over here. Let's see if the whole thing, nope, the whole thing will not move, so I've got to go back. Back button is my favorite button. My dogs are coming in, so they might be obnoxious. Control C, Control V, grab it and pull it over here. Now, I'm going to grab this electron from the lithium that's donatable, and I'm going to put it here. Now, this lithium is happy. You see, it's got no electrons around it, but this oxygen is not. So my only option here is to grab another lithium. Control C, Control V. I'm going to grab this lithium and I'm going to pull it over here. It did not pull again. Control C, Control V. Grab in the center. I always forget to grab in the center. Click away. Then move this electron here. Now this lithium is happy because it has no electrons in its extra shell, and this oxygen is now happy because it has 8 electrons in this shell. So now what we're going to do is we're going to name this lithium. Now I'm going to push Control, comma, and then 2. That's going to give me a subscript. And then Control, comma, out of it again, and I'm going to put oxygen. Okay, I've got 2 lithiums, so lithium 2, and I've only got 1 oxygen. O1, but we don't write the 1. Okay, now we're going to name it. We're going to write lithium, oxygen. We're going to change the gin to ide. So it's oxide. And I'm going to delete that Y because that's not how you spell oxide. Okay? Now, guys, you cannot do anything but add more lithiums or add more oxygens. You have unlimited amounts of lithiums and oxygens to add. Sorry, guys, I sneezed. Okay, so we've got one more. All right. This one is lithium and nitrogen. So we get, again, we know lithium is a 1, and we know it has 1 valence electron to donate. And nitrogen is right here. So I've got 1, 2, 3, 4, 5 electrons. So 1, 2, 3, 4, 5 electrons. And I know it is missing 3 electrons, so we are a -3. I can also do that by finding carbon is a -4, so I'm going over 1 to the right, so that is a -3. So now I'm going to grab and make a copy of lithium, Control C, Control V, hover over it right in the middle, pull it over. Let's do the same with nitrogen, Control C, Control V, hover over it, and pull it over again. Now we're going to grab this electron and put it right here. So that lithium is happy, but this nitrogen is still not happy. So our only option is to grab lithium again. Control C, Control V. Now, when I was your age and I was trying my best to do this, and y'all know I struggled in science, I kept trying to figure out how to get around this. Don't figure out how to get around it. Just do it. It's going to be wrong if you try and figure out any other way. So this lithium has donated its electron to nitrogen. It's happy, but again, nitrogen is still not happy. So now we're going to grab this whole thing. Control C, Control V, grab it, pull it in, and now I'm going to grab that electron and move it here. Now that lithium is happy, and finally nitrogen is happy. So our formula now is lithium, and then I'm going to go Control, comma, 3, because there's 3 lithiums, Control, comma again to get out of subscript, and capital N. We've only got 1 nitrogen. So now this is going to be called lithium nitrogen. Nitrogen is going to change to nitride. So this is going to be called lithium nitride. Okay. Now, my things are different from yours. You're going to do the same thing, but you are going to grab your electrons from here and here. You are going to have to build out your Lewis dots. Okay, you can still use the copy, Control C, Control V. That's fine. Now you are going to be faced with the polyatomics. Remember, the polyatomics you are going to treat as a single unit. You look on the back of your periodic table. If it says negative, that means it is a -1. That whole unit is to be treated just like carbon. And if it says negative, it's a -1. If it says positive, it's a +1. Okay? Now, I'm going to make this a little bit overlap more because I need some more space. So here's some more examples. Okay? Now, we're going to name these. I'm going to show you a quicker way to name these and a quicker way to figure this out. All right? So, watch what I do here. So, lithium is a +1. And I'm going to try and get hold on, I'm going to try and get this into a tablet mode. Okay? And hopefully you can hear me. So this is going to be lithium and fluorine. Now, here's the cheat way to do this. You see how lithium is a +1 and fluorine is a -1. All right? So what you're going to do is get rid of the charges, and this number comes down here, and this number comes down here. Now, I call this crisscross applesauce because that number crisscrosses down there, and that number crisscrosses down there. Okay? So I'm going to go back to this. All right. Sorry, guys. I've got to put my keyboard back on to get this hooked back up right. All right. Now, the next thing I need to do is find the charge for oxygen. I see carbon is here, so it's a -4, -3, -2. So oxygen is a -2. So I'm going to go back here. So oxygen is a -2. Okay? So we've got lithium, which is a +1, oxygen, which is a -2, okay? This 2 is going to go down here. This 1 is going to go here. This is lithium 2, oxygen 1. This is called lithium oxide, okay? Now, I tell you what I'm going to do to save me some time here is I'm going to go back here. I'm going to grab this and pull this back into here. Go back there. All right. Control C. Delete that. Go back here. Control V. Enter. All right. So the next one I am looking at is nitrogen. So nitrogen, here's carbon is a -4, so nitrogen is -3. So I'm going to go back here. Nitrogen is a -3. So I've got Li, which is a +1, nitrogen, which is a -3. This number goes here. That number goes here. So it's Li3N, and it's going to be called lithium nitride. Okay? All right, let's try something harder. Let's go with aluminum and let's say aluminum and phosphorus. Aluminum and phosphorus, Al +3. Phosphorus is a +3. Or sorry, it's a -3, sorry. Phosphorus is a -3. So this 3 goes down here and that 3 goes down here. But here's the deal. When you got subscripts, you need to take them down to the lowest common denominator. So this will actually be written out as ALP because 3 divides into 3 one time. So it's going to be ALP. Okay? So let's look at magnesium. Magnesium is a +2 and phosphorus is a +3. So this is Mg, which is a +2, P, which is a -3. This 3 goes here, this 2 goes here. So it's magnesium 3, phosphorus 2, or it's called magnesium phosphide. Okay? So I'm going to erase all of this. And I used to be able to just do a nice big circle and click. Wow, that worked. Excellent. Now, we're going to talk to you about polyatomics. Now, polyatomics are compounds that are bonded as single units that only have one oxidation charge for the whole unit. Now, your polyatomics are on the back of your periodic table. Okay? And these are basically the same ones that you have. I think it's actually exactly the same one that you have. So, ammonium, NH4, is a +1. Acetate, C2H3O2, is a -1. Chlorate is ClO, it's a -3. Nitrate is NO3, that is a -1 charge. Hydroxide is a OH -1. Carbonate is CO3 -2. Sulfate is SO4 -2. Phosphate is PO4 -3. Remember, if it is a negative, it is a nonmetal. If it is a positive, it is a metal. So this one is the only metal here. All the rest of them are nonmetals. Okay, so this next section is bonding with polyatomics. So this works exactly the same as the others. You've just got more letters to write. So what I'm going to do is go back and forth, and I'm going to go ahead and put the charges on each of my polys. So C2H3O2. So C2H3O2 is a, hold on, forgot my pen, is a negative -1. Okay, CO3 is a -2. Oh, it's still charging. Never mind. Okay, ClO3 is a -3. So on lithium, you would put LiC2H3O2. Okay? On this one, it would be Li, this 2 goes down here, and Li is a +1, so it would be CO3. We don't have to do anything with another subscript. All right, this next one is Li. This number comes down to here, ClO3. Okay, Mg is a +2. Now, this gets a little trickier when it gets this way. So here's what happens. Hold on, guys. Sorry, guys. Let's see if we can deal with this now. Nope. Just hold on. It's making me keep my keyboard on. Okay, I'm going to have to keep my keyboard on here. So, Mg +2, and we have C2H3O2. So we're going to say, Mg, and then C2H3O2. Now, because Mg is a +2, if I put a 2 right here, just like I would with anything, this would say this was a C2H3O22. That's not true. What you have to do is put it in the parentheses. Okay, remember I told you to think of that as a pregnant belly, and the subscript on the outside tells us that there are twins in the pregnant belly. So it's Mg parentheses C2H3O2 close parentheses squared. Okay, and when you're naming these, you do not change the endings. So all you're going to do is said magnesium, and then I don't have the name of this right off the top of my head. You're just going to name it however the polyatomic says to name it. Now we're going to do the same thing here on M, G. Now this 3 is going to come here. And then C, L, O. You're going to put parentheses around it and do 2 right there. Okay? So hopefully that shortcut will make everything easier for you. I did find something cool. I could do that. And everything's going to go all over the place again. Go here. Come on, give me what I want. It's not giving me what I want, guys. Oh, it's right here. All right. Now let me clear everything here. And then I'm going to go back here. Just stick with me, guys. All right, so again, when you're naming, you write the first elemental name of the metal first, then write the second name of the nonmetal, drop the last syllable of the nonmetal and add "ide." The only caveat on this is if the second material is a polyatomic and you are just going to name it the way the polyatomic names it. Okay? So, let's practice this. All right, I can't do the polyatomics because I don't remember all of those names, but KCl is potassium chloride. FeCl3, iron chloride. CrF2, chromium fluoride. Aluminum sulfide. Iron chloride. Chromium fluoride. And then I don't remember what these are, so I can't do them, guys. Not off the top of my head. Sorry. Okay, do not worry about this. Just skip this. Okay, so we're done for this. Have a good day, guys. I will